Hi everybody, here we are. I'm in the middle of the Black Butts Forest, National Forest, on St John's Wood Walk. I thought that might be a nice spot, right in the middle of the bush here in my lovely Gordon in Sydney, Australia. And I want to talk to you about something that came from the Psychiatric Times, which I thought was very interesting, a very interesting website. Now, it's a paper written by Dr. James Phelps, who writes quite a bit for them, on the nature of bipolar and antidepressants and their success or lack of success. And he's reporting on the International Society for Bipolar Disorders meeting and a discussion between two experts for and against. And there's just actually not a lot for the antidepressant argument because, of course, it has a tendency to send bipolar people manic. Now, what they talk about in here, which is really interesting, is 9 alternatives to the antidepressants. Now, 3 of the natural ones they talk about: exercise. First, yes, exercise is everything. We are an active body. By exercising, we activate our body and activate things. CBT, so talk therapies. I mean, we always talk about CBT, but remember that's the one that's most researched. But talk therapies, integrated interactive therapies, and light therapy. Now here we're talking about sleep and melatonin levels, and of course sleep is enormously important in the ability for the brain to regulate itself. So that's important. Now in the natural pills, they call it natural pills, omega-3, yep, sure, your fatty acids, your fish oils. Now of course they're helping the brain function, helping neurons function, helping membranes. They sort of moisturize the brain. They're really useful. N-acetylcysteine, now that's an amino acid, and one of the amino acids, it's important in producing proteins. It's used for all kinds of stuff. People take it for, well, I've written down some: angina, Alzheimer's, cholesterol, infections, and even some cancers. It's all for helping to produce proteins to help us function more successfully. And remember, everything we produce, everything that happens to us, happens because it's a protein that DNA has expressed. And the other one was optimize the thyroid. So thyroid's terribly important in the nature of behaviour, and again all a part of that pituitary sort of axis of activity. In the pharma, lithium, well, lithium is seen to be one of the most successful pharmacology aspects. Lithium is great, very difficult in its dosage, and remember it's also used in batteries. Be careful. So lithium, now lamotrigine, sometimes known as Lamictal in its ordinary thing. Now that's an anti-epileptic. Now that's interesting because as an anti-epileptic, I'm having an epilepsy with the epileptic, anti-epileptic, it's a sodium channel depressor. And sodium, movement of sodium channels in the synapse is how we actually create an action potential. So by depressing or suppressing the movement of sodium through the sodium channels, then you are suppressing action potentials, and of course then you're suppressing activity in the brain and potentially epileptic seizures. And the last one is quetiapine, which is one of the antipsychotics, the second generation antipsychotics, and quetiapine, of course, working on the dopamine system. So all very interesting aspects of ways in which depression can be treated for the bipolar without causing all kinds of trouble for the mania, which you might then trigger off. So check that out, Psychiatric Times. Hey everybody, here we are, Friday again, looking at what's going on, what's happening this week. Interesting paper. First of all, one I just want to mention, which you should go and have a look at. I just did this. It's in Scientific Reports in their number 4, article number 4010. Different yawns, different functions. Now that's by Alicia Leone et al. Now I'm not going to tell you more about that. Go and have a look at yourself. But yawns, there's another thing that needs a look at from the neuroscience point of view. But the one that I want to talk about is the systematic review that was done. Now it's in Brain and Cognition. It's not out for a while. It's actually for their April edition, so in volume 86 in April 2004, and 2014. That'll be page 1 to 9. And it's working memory improvement with non-invasive brain stimulation of the dorsal prefrontal cortex. It's a systematic review and meta-analysis. Now, these meta-analysis and systematic reviews are good to look at sometimes, partly because it saves you a lot of reading, but also it gets down to some detail of where the thinking is going. Now, what they're talking about is the transcranial magnetic stimulation, TMS, and they're looking at the ways in which, by stimulating the dorsolateral prefrontal cortex, that this builds up and increases the capacity of the working memory. What they found was principally it did, which is very good. And there's two things in this. One is, okay, TMS, yay, we stimulate the dorsolateral prefrontal cortex and that improves our working memory. But the other point of it is that why aren't we stimulating, or what is it that is not being stimulated in the dorsolateral area of the prefrontal cortex that we might be able to do by our own perspective? What is it that's holding it back, that's restraining it if it has this increased potential? So those are interesting things to think about. How can we train the brain, how we can do brain training to activate and keep that prefrontal cortex variously active in its different aspects. Of course, interpersonal neurobiology, Dan Siegel's aspect there talking about it. So have a look at that one in Brain and Cognition.
Hi everybody. Well, here I am in my new clinic rooms, which we've been building and getting all together over the last 6 weeks, so that's kind of exciting. But let's have a look at what's going on. I've been having an interesting conversation with my friend Professor Alan Ivey, counselling, very well-known counselling micro techniques in the States. And we've been talking about a lot of things in neurobiology, and oxytocin, the oxytocin receptor. And he was sharing some papers he was talking about in relation to the importance of the oxytocin receptor, some of the polymorphisms, the SNPs that can change it, and that oxytocin receptors are important for being able to develop good attachments, and it helps, that it benefits. And so I talked to him about epigenetics, and so we added a talk about that. Now there's 3 papers I want to bring to you that are important in relation to this attachment, the epigenetic, the genetic nature of our capacity, our potential, or the framework in which we develop our attachment stuff. There's a new chap, and that's why I want to share it with you. So let's look at the new one first. That's interesting. A guy named Robert Kumster, K-U-M-S-T-A, Kumster, doing some interesting work. Now this is actually from 2013, so an old paper, a year old. But epigenetic regulation of the oxytocin receptor genes, implications for behavioural neuroscience. So that's Frontiers of Neuroscience, volume 783. You'll have the connections and the links downstairs. And what he's talking about is the nature and the way our behaviour and our experience and our attachment experience and our trauma experience has an effect on the oxytocin receptor gene. Because remember, it's not so much that we have the oxytocin or serotonin or dopamine or any of these things wandering around our system. It's what are the receptors doing in relation to those chemicals, because if we don't have the receptors, then we're in trouble. And see the SSRIs, that's a reuptake, it's receptors, it's receiving, it's what they do in with the chemicals, what the body can do with the chemicals, whether they're present or not. So that's very interesting. Now what that led me to think about was, of course, the importance of oxytocin in relation to this interpersonal work. And of course, one of the places where they've been looking at this is autism. And what, of course, one would expect they found is that the autistic people don't have good receptors. And so here is another paper by Gregory et al., quite a few of them, looking at genomic and epigenetic evidence for oxytocin receptor deficiency in autism. And this is actually a 2009 paper from BMC, Biomed Central Medicine magazine. Again, the links will be below. And looking at this nature of the lack of the oxytocin receptors in autism. And so, okay, so if we're reducing the nature of our oxytocin receptors, and this can happen through attachment and poor attachment, and I suggest also through the aspects of isolation, through the aspects that this is a traumatic event, these isolating things, these diminishing our interpersonal relationships, and my theory, the winner-loser world, where we actually become defensive and hold ourselves back from other people, that this actually causes a reduction in our oxytocin receptor genes. And to some way, this is how I use the term, we are autisticating our culture, autisticating our kids. So we're not making them autistic, but we're autisticating them. And just the third one to remind you of, to have a look at, which is in relation to the glucocorticoid receptor gene, in the hippocampus, which is very important with our stress and early trauma and early attachment issues. And just reminding you of that epigenetic regulation of the glucocorticoid receptor in human brain in relation to childhood abuse. And that's Patrick McGowan, Michael Meaney, really terrific people doing that work there, Moshe Ziff. And so that's again a 2009 paper. We'll give you the link to that. So that's really cool.